I would like to thank to Dr. Abraham Johnson and all organization group for the invitation and the special opportunity. Here is where I live, in Feira de Santana City, in Bahia State, in the northeast of Brazil. We have 26 states in Brazil and one federal district, and we are in the northeast position. The 3D printing forensic odontology began about 10 years, and with the spread of 3D technology, the advantage of this tool and the reduction in operating costs, 3D print increased here in Brazil and in other countries. The main advantages that we have are alternative to duplicate fragile objects, reconstruction of crime scenes, bones and bodies reproduction, provide long durability, provide international cooperation, okay, a minute.
Okay.
No. Okay, I have a little. Oh, excuse me. I will go to the. Okay. Well, in 2010, during a big congress in Salvador City, I attended a presentation about rapid prototyping and engineering applications in health field, the CIOBA. It was, at the time, I thought it would be useful for forensic dentistry. And we started to create research in that line. In 2011, we had a postgraduate 10 in our specialization course in forensic odontology in Salvador, and we began to study this area. We made some partners with technology center of Senai Cimatec, and we used the 3D scan to scan the chocolate, and we used it to the first 3D printing in our states are these two, and they are in Salvador, 100 from Feira de Santana, that is the city that I'm in now. And we use the chocolate sample, we use the cake sample, and this is our first 3D print for forensic studies. The chocolate and the cake, and we could make the to compare the dental plastic model with 3D print of chocolate and cake, and we saw that it would be a good way. One more I made that you can see, make this comparison, and we use it to the 3D digital analyze. It is a good option when we can't to print. We made this test too, and could see a lot of compatibilities between the Byte foods and the main suspect. This was another suspect that we could compare in a simulated case We have used a lot of simulated cases here too, with the cake and the one of the suspects. We had 3 suspects in this study, and we could test to in 3D analyze on skin, which was the second step. We could scan the skin surface of our student that made a self bite mark in those moments, and we could to test the possibility to scan this surface, and we had good results, and we can see so the yellow suspect and blue and others. Like I told, we had 3 suspects in this study, and we could compare the dental anatomy and the impressions on the skin, and we can see the difference with good quality in this with this tool. Another point of view. We can look in a lot of point of view in this situation. Now the bite mark impression, the suspect one, we can see the total all the compatibility of the marks and the dental characteristics. The other suspect with different anatomy, and the third suspect. Another, we can see under the skin, this technology, we can see under the skin because the scanning, surface scanning, so we can see the contact points of the teeth, the tools. One suspect, the yellow, and the second is suspect, and the third is suspect. And everybody together, we can see too. Okay, one view more. We have some other partners. Here we use the scan, a 3D scan of the University of Coimbra in Portugal, where I made my postdoctor with analyzing bite mark in 3D, and we could to scan this cookie with chocolate. We used this equipment and could make a good file, 3D file, to 3D analyze digital and to print. Some point of view. Okay. And we had a 3D model, a fidelity model of the skin. We could test another way to scan during the postdoc, and we analyzed the use of cone beam CT to 3D reconstruction, and we had good results. We could to scan an apple and the other kinds of foods with a sufficient quality to compare with the simulated case with some suspects, and we could use a bell and pasta, pizza, because we know the difficulty to scan some kinds of foods and some kinds of objects, and this is an alternative. We use the iCat program and equipment to make this, to scan the apple, and we liked the results of the capture of the image captures. Okay, and we can analyze it in a lot of point of view too. The bell and pasta, we could make a good digitalization, a good scanning. We tested a lot of other kinds of foods and objects, and we can analyze in a lot of point of view in this situation too. Normally we use the Invesalus, is a software that we use to create the 3D image and to export and make. We use open source softwares too, like this MeshLab and NetFab. And this is our laboratory. NIEPFON is the interdisciplinary nucleus of forensic studies and research. Here in our university, in UNEF, is our main space to create equipment. We created this tech Byte, this simulator of bytes, Byte mark to study on skin, and objects, on foodstuffs. Here we have some pictures of our laboratory. We have a room that simulates a crime scene, a permanent place, and we can make a lot of simulations and to use to study with students. Our photography table in the other place. And we have trainings, simulations. We have an administrative room and a 3D place with a 3D printer. And we have tried a lot of kinds of objects, like reconstruction, facial reconstruction of the skin and of the bones. We use another kind of 3D scan to test. We have make a lot of tests in a lot of kinds of equipment, and we have make the dental models and foodstuffs with bite marks. Here we have some of this, a lot of kinds of fruits, the 3D print, and we have tested in a lot of moments with the surface scan of the face. We could test a good way to print, to reproduce the face. We use NetFab Basic to analyze in 3D, digital 3D analyze, in bite mark analysis, to make the comparison and to compare. Sometimes we use the 3D print, sometimes we use only 3D digital analyze. And here we use repeater host to plan the print. Here the step that we use to print. Here part of a body. We tested it to print the frontal sinus. We can reproduce in 3D view and to make the impression, the 3D print. And we have, when I research with several frontal sinus comparison, it's very easy to compare the frontal sinus when we have them in our hand printed, not only in B-dimensional way. We are very happy with these results with frontal sinus and body surface, part of the body or all the body. Here we tested it to me. This is me that we made the scanning, and we planned it to the impression, the printing with NetFab that we use, and all the body scanned to print to test, because we can reproduce the crime scene, the characteristics of the suspects. We can see the face. We have the face in our hand, in front of us. In other moments, with skull, with bones, parts of the skull, we can use bodies. We can create simulated bodies with some softwares like Make Human. We use to create bodies, simulated positions of the situation, and make the 3D print. And we can study the firearm injuries. We tested to print using a tomography, a computer tomography, multi-slice with this cow head in a hospital that is partners of our center too. And here we in a scanning the suspect, the simulated case in Byte, and we scanned the suspects and the apple and the other kinds of foods that we had with Byte. We tested it. We have tested, I said, a lot of ways, because we need to show options to forensic centers that don't have this equipment, but with partners is a good way to make this kind of analysis. So we had this 3D print, a set 3D. This was our first 3D print, our first. Maybe 8 years we have this. It's working. Printing a dental model here in the part of the laboratory, and printing a lot of Byte objects. We have daily printing and analyzing these kinds of analysis. Here we are we have another research with 10 suspects that we made the 3D print of the dental models, and we are comparing with this each food, Byte food. We are comparing to discover which suspect Byte them. Now we are using to scanning intraoral scanning the 3D shape. Now this was maybe 2 months before that me and other students of our team and our partner too, the partner Odontology, that could to scan intraoral 5 suspects. The mine was only to test, and can scan 2 with good results. Some objects, foods, and other kinds of objects, and we can analyze in 3D, digital 3D or 3D printed. And a simulated case of a Byte, the newest study that we are making this year, again with 3 shape. We used them to scan the chocolate, the Byte chocolate, printed them with another kind of 3D print that we have. We used the 5 kinds of fruits. We made the impression. We printed it with PLA, a kind of material that we use in this kind of 3D print for suspects, because I wasn't the suspect. The mine was only to test. I didn't see who bite and eat foods. I had the work to compare and to analyze and to understand what happened. Here, comparing, and one of the food, a cookie, and a suspected dental model. We use, like I said, we use the PLA material. ABS we use too. We use it normally. We have used the ABS and PLA to print. Here we have a moment of comparison, comparative moment, and it was relatively easy to compare and to say who bite and eat kind of food. It wasn't easy to confirm. Comparing here too, we need a good quality of teeth mark reproduction to have sure who, and to can say who bite and then another image. Yeah, and I tested it too. My skin not so strong bite, but I made one test in one moment, and we tested how to would be the quality of this kind of scan in this situation, and the 3D print with PLA2 material, and we are glad with the results. Here we can see better the bite mark, my finger, and the models with cubic resin, another kind of impression of print, 3D print with another material. And we have a lot of possibilities with 3D printing. We can produce protective equipment. During this year, we used it a lot this way. It was an alternative, a good alternative that we could help. Now we can see two other 3D prints that we had and bigger to print face shield and the other kinds of protections. We tested and could help a lot of professionals in the front line in our city. With 3D print, we can help too. We made donation to a lot of health centers and the other. Here is a laboratory that we created on the UFs, on the State University of Feira de Santana, where I teach too. We made a big difference in our space. We can do research. We have some monthly or maybe on times, possible times we are making new researches, testing, and making taking another knowledge in this area. We can do forensic arts too, like Dr. Abraham Johnson. We can do forensic arts that's very impressive in this area. And final considerations, 3D print technology is feasible and one or more tool in solving forensic odontology case. Here are some our main books in Byte and 3D print too, related to Byte analysis, and our newest book that have parts with 3D print, maybe the first book in Brazil with 3D print to use in forensic odontology. So this is in the moment this is the main book that you are be using in universities and the other ways of to study, and we have part of them with 3D print and a little bit of Brazil. I hope one day you can visit Brazil. Some places, amazing places we have too. A little bit of Bahia State, in where we live. Foods, traditional foods, and very, very beautiful places to visit, and parties, amazing parties we have too. In Carnival, this year we didn't have no parties. You have beats, amazing beats too. And here a little bit of Feira de Santana city, where I live. Here a little bit of our universities, UFES and UNEF. And thank you very much. Thank you, Johnson. Thank you, colleagues. Thank you, everybody.
Thank you, Professor Jadesden. It was a wonderful presentation. We could understand the bite marks specifically, how the 3D printing was utilized along with the application of the 3D scanning. Now, let me take an opportunity to welcome Rachel onto the dais, and she will be talking from a very different perspective from the anthropology and archaeology. So over to you, Rachel.
Is it okay?
Yes.
Thank you. Okay, so yeah, just a quick talk about 3D printing across the forensic sciences and to give a UK perspective. So I'm a PhD candidate for the Centre for the Forensic Sciences, which is in the Department of Security and Crime Science at University College London. And I'm also a part-time lecturer in forensic science at Kingston University, again here in London. So of course there's been a rapid development and utilisation of 3D printing technologies in engineering, healthcare, dentistry, all different disciplines. And this is now expanding to go across the subdisciplines within forensic sciences. This potential is just beginning to be recognised. However, while the application of 3D printing in forensic science is beneficial, currently there's limited research demonstrated in the literature. And we also have a limited demonstration of the application of 3D printing in forensic cases in the literature. So today I'll just describe how 3D printed replicas can be applied in different scenarios in police investigation, as evidence in the courtroom, and across different disciplines. So in courts in England and Wales, here in the UK, 3D printed exhibits are already being used in the courts as demonstrative evidence, since the laws in England and Wales permit the use of these novel technologies on the basis of expert opinion. So we have the 2015 Criminal Procedure Rules, which stipulate the rules around expert witnesses and the admissibility of evidence. And of course, expert witnesses are uniquely permitted to provide evidence of opinion. And the expert witnesses can also admit exhibits to the 3D prints. They can use them as visual aids and actually admit those into evidence to support their testimony. And we do have a few small criteria in England and Wales, just that the evidence is relevant and reliable. And a key part of that is the integrity or the accuracy of a 3D print as evidence is really key. And this is something that's going to be affected by the techniques and methods that we use. So in the UK, we don't have very strict evidence criteria like the Dabo and the Fry rules that you get in the US. It's much more flexible. But we do need more empirical research to underpin the integrity of the 3D print so that it can withstand cross-examination in the courtroom. So quickly, some of the advantages. So 3D printed replicas allow for a higher level of interaction by the observer, because users can hold, they can feel, rotate the object in their hands. So this is the jury, they can hold the evidence in their hand while the expert is talking. Of course, we can use non-invasive and non-contact scanning techniques, which provides a more ethical workflow. So this doesn't further disturb any human remains or trace materials on those remains. Models can also be re-evaluated or reprinted years later. So after the original bones have degraded or been buried or cremated, we still have that original scan data and can reprint them when needed. 3D prints, of course, the object can be scaled down to fit within the printer to make it easier to hold. So if we have a whole crime scene, we can 3D print that so it's a handheld size. And conversely, we can scale up small features to make them more visible to the naked eye. So if we have a fingerprint or a small fracture, we can scale up that object so that the juror can see them for themselves. Of course, replicas can be printed in a range of materials and colours and textures and flexibility to try and make them more interactive or more eye-catching. And of course, there are many low-cost options available with very cheap 3D printers around nowadays. And then some of the limitations. So 3D printing an object, it's limited by the initial documentation process, so the scan resolution. And there are some very high-cost methods if you have the more expensive printers. We can also have defects on the prints, so we have step artifacts from the scan lines, or problems with support structure removal and build rafts. Sometimes they can't be removed from the inside a print and we have to keep them there. Prints can also be anisotropic or lack robustness. It's not particularly strong in all directions. And we also have the powder-based methods, the selective laser sintering, which can result in a granular or brittle surface. This has the really fine powdery material which sort of comes off on your hands. And a huge limitation is that we still need validation of the 3D printing techniques for courtroom applications. And finally, also there's little exploration into the risk of bias in the courtroom with a 3D printed model. So we don't know to what extent a juror holding a 3D print is biasing them in favour of the prosecution. So we've come up with a set of 6 key considerations. So we think that a 3D print should be a true representation of the original material. You also have to consider whether the 3D print is just a demonstrative aid in the courtroom or if actually being admitted into evidence. Always remember the rules of admissibility. And again, distinguish between findings and simulated scenarios. And ensure that the courtroom has understanding which one of these you're talking about. We should also consider the value and the prejudicial effects of exhibits. So again, it's that bias upon the juror in the courtroom. And the interpretation of evidence by the jurors. Are they being distracted by holding a 3D print, or does it help them to better understand the expert testimony? There's a couple of studies that looked at this recently, but we don't yet know the full extent. So I published this paper, an overview of 3D printing across the forensic sciences, just earlier this year with my colleague, Dr. David Erickson from Cranfield University. And so we came up with the idea of this paper because we know that there are so many different scanning techniques out there, and they're being used in very different ways in different forensic science subdisciplines. So we kind of wanted just to have a review of that see where they're being used, who is using the scanning, who is using the printing. So we came up with a set of potential applications. So I'll just go through some of those now. So the first one we have is crime scene reconstruction. So for this paper, we 3D printed a replica of a mock crime scene. So this crime scene features, so it's just a mock crime scene. It has the dummy or mannequin on the floor, and there's also a handgun on the floor. You can just about see. So this is just a really quick prototype we made. It's just a handheld size, and I think it quite effectively gives the user an overview of the crime scene. You can hold it in your hands, turn it around, see the different elements in that room and how close they are to each other. And just for reference, this is a photo of the crime scene, and the white 3D print here is another prototype we made using a different printer. You can see the handgun there a little clearer as well. And it's just also brought about the fact that different printers and different colours can alter the visual impact quite significantly. Another potential application, of course, ballistic reconstructions. So bullet trajectory reconstructions can now be generated using a variety of digital imaging techniques, and trajectories within a human body, both the living or decedent, can also be modelled to show injuries or to understand the sequence of events. So while digital imaging has been applied in bullet trajectory reconstructions for some time now, there's not much evidence of research extending this into 3D printing. So this is a study that I'm working on currently. The upper image here illustrates a gunshot trauma that was 3D printed from a post-mortem CT scan. And so this print has been measured and it's been shown to be accurate. Measurements taken from the gunshot wound could also potentially be used to estimate the caliber of a bullet from the 3D print. And something you can see on the 3D print is also the very small bone fragments were printed out in situ on the print. And this is something that would have been lost in a post-mortem examination. So this provides a really important and useful reference material. And this lower image here also shows the pathway of a bullet through a printed culvarium with the inclusion of a 3D modelled rod to show the pathway of that bullet from the entry through to the exit wound. And again, this is just a really quick and easy prototype. It's only a 10% scale model, just to illustrate the possibility of creating this 3D print, which shows the sort of position and the directionality of a bullet. Another application is pattern and impression evidence. So the picture here is actually a photo from a case that was published by Byte in 2017. In this case, they were able to micro CT scan some bone fragments that were burned and dismembered. They were found in two different locations. And they were able to scan those bones and recreate them with 3D printing. And it really, really clearly shows that these two bone fragments they fit together. And so they came from the same person, the same individual. And so they linked a suspect to two different crime scenes. So this was a UK case from a few years ago. And there's also the other potential of so pattern impression evidence, so scaling up prints such as fingerprint marks or footwear marks, just to allow the examiner or the juror to inspect these fine details as well, similar to the trauma pattern you can see on the bone here. Okay, another application we have is forensic archaeology. So forensic archaeological sites such as clandestine graves and mass graves contain a lot of different types of features that could all be forensically relevant. So we have human remains, the personal effects, the vegetation, as well as patterns and impressions, so marks from spades or tire tracks. And by using 3D recording process, we can potentially capture entire sites and record graves and remains in situ, which is particularly useful as these marks are going to be lost over time and lost with the weather. So again, this is a 3D printed prototype we created here of a mock mass grave. So there's two grave cuts intersecting with each other. And in the upper corner here, you can also hopefully just about see there are two tire tracks. So tire marks that are left by the digger that created the grave. And this was just another example of something we could potentially be creating for use in forensic investigations, and we were really, really pleased with the results that came out from this. And of course, another application we have is forensic medicine. I know you've been hearing a lot about that this weekend. I just wanted to briefly touch upon this case, which was presented in the UK media in 2016. It's a case of a 6-year-old girl who died of severe head injuries, and the prosecution 3D printed this skull and brain of the child. And they were able to show these 3D prints within the UK courts to demonstrate her injuries. But for me, the highlight from this case was a comment from the defense lawyers. So they argued that the skull and brain were just an interpretation of the CT scans and not entirely representative of the evidence, which cast some doubt on the accuracy of the print. And this led me to think about how we can demonstrate that such prints are accurate and not just someone's interpretation. Of course, another thing that 3D printing is especially useful for in forensic medicine is evidence, again, that will change over time. So if you have a healing bruise or bite marks that we've just heard about as well, these can be successfully recorded with surface scanning and 3D printed as well. Another area we have is forensic taphonomy. So the 3D documentation of taphonomic processes have been addressed by a number of authors, but the potential of 3D printing these very minor details is largely unexplored. So there's potential for 3D printing and archival in this format, and 3D printing of human remains that were documented in situ can also help to understand the post-printing changes that have happened to a recovered skeleton. So this figure at the top here shows a 3D printed infant cranial fragment, and this piece is extremely thin and fragile, but it was successfully captured using CT scanning and 3D printed, which creates a really nice replica and quite clearly shows the shape of the material and even captured the sort of fine wavy edges. And then we have the lower image here, which is an adult cranial fragment. This one has a lot of root etching on the surface, so it's being exposed to the other elements, and it has a lot of taphonomy. And this root etching was successfully captured using micro CT scanning and just printed simply on a cheap desktop printer, which I think quite adequately recreated those features on this 3D print. So there's also the possibility of creating a multi-layered printed model, so a model which has removable layers or pieces to help demonstrate taphonomic processes, or even sequential models that demonstrate how the taphonomic processes change over time. Okay, so another area we have, of course, this is my area of speciality, is forensic anthropology. So forensic anthropology appears to be a little bit slow on the uptake of forensic imaging in the UK, and therefore certainly 3D printing is not really being used to its full potential either. Research in the past decade has investigated applications of CT scanning, so I think this is starting to change. So anthropology in general relies really heavily on visual analysis and visual comparison, so it's well suited to the creation of physical replicas. So when 3D printing is combined with volumetric imaging, internal bony structures that would normally not be visible can also be 3D printed for analysis. So for example, printing out internal structures such as cranial sinuses or a hyoid, as we have in the picture here. These can be beneficial even for teaching or for courtroom purposes. And these are also particularly useful in creating a biological profile in forensic anthropology. So the lower images we have here, the 3D print of a pelvis and also a juvenile clavicle on the right. So these are 3D printed to assess the surface quality and just to see if we could use these in biological profiling. And I'll come back to that in a moment. So this was the first major study I had from my PhD. So looking at the accuracy of 3D printed bones through testing out different CT scanning and modelling parameters. So just as a snapshot, we printed 3 different bones on 6 different printers. And overall, we found that the prints were on average accurate within the ideal range of plus or minus 2 millimeters. There was more variability in the intra-observer variability, but this was probably just due to measurement error rather than inaccuracy of the prints themselves. So in the photos here, you can see the metatarsal replicas, and there are obvious differences between the prints in material, color, and detail. So we have the top middle one here, the MKB printer. This has quite a messy surface, even though the resolution of the print was the same as the others. So it just kind of shows the variation between the different printers that you can get. And so the results from this study did provide some recommendations for achieving accurate prints of human remains. A key finding was that the SLS printer, so the selective laser sintering, the powder-based method, this was selected as the most accurate printer type, which produced prints that were the most aesthetically true to the original bone. Although this SLS printer is quite an expensive model, but we did find that in general all of them were accurate, so we could really be using any of these types of printers. Another study that I did, so looking at the surface quality of the 3D prints, this is creating these bones again. So we have the pelvis, the skull, several different bones. I firstly double-checked the accuracy of these prints as before, and then looked at the possibility of applying age and sex estimation methods on the prints. So the results of this confirmed again that the prints were accurate within 2 millimeters of the original bone. And generally, we found that observers were able to confidently assess the gross features of these prints. So the overall morphology or the shape was accurate. However, the fine surface details were not always well represented compared to the drying bones. So these really fine details you get, like microporosity, macroporosity on the bones, wasn't necessarily captured very well. So going back to that first paper, I showed you the overview of 3D printing in forensic sciences. With my colleague, Dr. Dave Erickson, we came up with the 6 key research questions. Questions that we think need to be addressed next so that we can continue to validly use 3D printing in forensic science. So we thought, number 1, how are 3D models being created? Who is creating the models? Where are these being created? What is their intended goal? How and where are 3D printed models currently being used within the forensic science framework? We have this suspicion that they are being used, but we've kind of lost that link between academia and practice. We don't actually know who's using them or why they're being used. So myself and Dave Erickson, we're currently working on these first 2 research questions. I'm working on a paper right now, 3D printing in UK forensic science. I'm looking at a series of case reports and lessons learned. So we've started a collaboration with several UK police forces and forensic practitioners to see where these prints are being used. And this has showed us so far that 3D prints are increasingly being requested and used within the UK courts of law. We have a range of cases ranging from 3D printed infant skulls to look at trauma patterns. And the more bizarre cases, we have a 3D printed whole body that was printed out inside a domestic freezer. So they printed a scaled model of a freezer, and then also a dismembered body to show to the police investigators that this body would have fit inside the domestic freezer. We've also found that several UK police forces now have their own 3D printers, and they will produce these prints themselves in-house. But they do also tend to rely on prior knowledge of relevant academic partners or collaborators. There are a host of materials that are being used. There's no single scanning method or printing type is preferred. And the findings also demonstrate that there is a clear need to standardize both the printing request procedures and the 3D printing processes, so providing protocols that can be there in readiness for the courtroom, and also further investigation into the potential effects that 3D printing may have on members within the court is also needed. The other questions we have, so number 3, who is best prepared to produce the 3D printed models? Should it be the forensic pathologist, the radiographer, the police investigators? Who should defend a 3D printed model in the courtroom? Again, should that be the pathologist, the anthropologist, the scientists? Do we need specific training for producing 3D printed models in forensic science? And lastly, here we have who owns a 3D printed replica in forensic science scenarios. So what are the associated ethical considerations with owning and created 3D prints? And what happens to the data beyond the close of a case? This is something that I'm currently working on as part of my PhD, so investigating the ethical considerations associated with 3D printing human remains in the UK. The results from this are currently being written up and include a framework or a checklist that practitioners can use to ensure that they are acting ethically. So do look out for both of these pieces, hopefully in the literature next year. So one of the last things we have from the overview of 3D printing paper was an agenda. So we looked at what's going on, what we think is going on, and came up with this agenda for what we need to do next to try and make 3D printing in the UK more robust and more valid. So number 1, we want to form a working group, something that can develop best practices for 3D printing in forensic science and act as a validation committee for the development of protocols. Number 2, a development of a primer for the use of 3D printed replicas in courts of law. And we also called for greater inclusivity between forensic science disciplines, multidisciplinary discussions and liaisons with other bodies, so getting together people from radiology, additive manufacturing, pathologists, odontologists, getting everybody together and consolidating our research, because we all do this research in slightly different areas and there's a lot of overlap. We think it'd be really, really great just to have a broader discussion. And finally, just to widen awareness that validation of 3D printed models is needed in forensic science. So just lastly, this first point on our agenda, the formation of a working group. We've just recently had discussions in this past year with the Forensic Capability Network in the UK, and they're helping us to develop this working group, a network of experts and practitioners across 3D printing and across forensic science in the UK and across the globe. We are starting to develop this network and then hopefully in the future develop these validation and protocols. And we just have the first meeting of this coming up actually this week. So it's a really, really exciting time in the UK for forensic 3D printing. There's a lot of exciting research going on and a lot of push towards sort of gaining this empirical evidence and ensuring that 3D prints are being used safely and to their best potential within the UK courts. So thank you very much, and thank you to Dr. Johnson for inviting me to be here today. And a quick thank you to Professor Ruth Morgan and Dr. James French, who are my PhD supervisors at UCL, and also to Dr. David Erickson from Cranfield Forensics Institute and Dr. Amber Collins from Teesside University, some collaborators of mine, and of course the Forensic Capability Network for helping us set up this working group and to get our agenda moving. There we are, thank you.
Thank you, Rachel, for providing the ethical and the legal side of 3D printing from the forensic perspective. We totally understand forensic science as the application of the science to the criminal and civil laws, governed by the legal standards of a particular state for admissible evidence or any particular criminal procedure. Moreover, as a forensic scientist, we do collect, preserve, and analyze certain scientific evidences during the course of investigation. We we look forward for new tools and techniques that makes our life easier, but that should definitely be much more scientific in the code of law. I'm sure with this working group and more scientific researches in the forensic science, we may definitely achieve whatever we have put down in the agenda. Thank you so much for once again for the wonderful presentation. Now I would call upon the presenter for the last presenter for the day. That's Dr. Gargi, who will be speaking from again a very different perspective. That is from that would be the virtual reconstructive forensics. Now I call upon Dr. Gargi.
Is it visible now?
Yes, you can put it in the slide share mode and you can start the presentation. Yes.
Is it okay?
Perfect, perfect. You can start the presentation.
So, first of all, I would like to thank Dr. Abraham Johnson for providing with this opportunity. I would also like to thank Dr. Shibu John and his team for providing this opportunity, and congratulate them for this organizing this conference. I am a forensic odontologist and presently working as a project manager at National Forensic Sciences University, and we have founded a startup company called InnovateWorks, which will be working in 3D scanning and 3D printing. Talking about three-dimensional reconstructive forensics. So, word forensic, the dictionary meaning of forensic is the utilization of the scientific techniques and methods to investigate a crime. So, why the reconstruction is needed in forensics? A major role of forensic personnel, and specifically when a forensic odontologist is involved, it is to establish the identification. And establishing this identification becomes difficult in the case where there is trauma to the human remains. So, reiterating this, when forensic investigation of the crime scene and the disaster sites require the analysis of the evidence, including the human remains. So, as a consequence of this destructive events, such as fire or trauma, the human and the skeletal remains obtained at times are fragmented, occasionally with missing elements, which may hamper the identification process. So in the current practices, these fragmented evidences are approximated manually for the positive fit, which are subsequently rejoined using glue or the tape, whereas the external integrity of the missing elements are restored using the dental wax. This is where the role of 3D technology comes in. So when this fragmented remains are handled, they are generally obtained the fragile state, specifically in the cases of burns. So the manual handling may not only pose as a biological hazard, but also the improper handling would lead to the further destruction of the evidence. Talking about the Indian law, the IPC section 204 states that the loss or the destruction of the evidence is a punishable offense. So here, using non-contact 3D scanning methods, acquisition of the data from the evidence can be performed merely by touching these remains, and 3D models generated are processed and which can subsequently be 3D printed, and this 3D printed models can be used for further analysis. So this is where we came up with the word reconstructive forensics. So this word refers to the reconstruction and remodeling of the fragmented and the missing elements of the evidence, with thereby reconstructing the profile of the evidence in question. So I would be talking on the reconstruction and the remodeling part of this fragmented and the missing elements. So at the Laboratory of Forensic Odontology, National Forensic Sciences University, we conducted a bunch of studies for the reconstruction of this missing and fragmented elements, and we came up with a general workflow. So whatever the forensic material we have, we usually scan it. We use a combination of 3D surface scanners, CBCTs, and CT, after which we process the models. In the case of reconstruction, we transfer it to the virtual environment and we reconstruct it, and finally 3D print this reconstructed model, and this model can further be used for the analysis. Talking about the first part, the 3D fragmented reconstruction. For the fragmented reconstruction, we conducted a couple of retrospective studies where we simulated the forensic situation where there was where we fragmented the skeletal and the dental remains. So it can be appreciated from the picture that we have fragmented the dental remains and the replica of the human mandible. Each of these fragments were scanned individually, and the processing was done of the model, after which these processed models were transferred into the software where they were reconstructed virtually based on the fracture lines. After reconstructing the whole or the complete model, they were 3D printed. Now, as we are talking that this 3D printed model can be used for analysis, but before that, it is very important to affirm that this 3D printed models are accurate and they are as good as the original models. So for that, we conducted few accuracy tests. So the accuracy of this reconstruction, first of all, we examined the morphology of this reconstructed and printed models. So from the metric analysis of the mandible, we were able to say that the discrepancy was between 0.02 mm to 1.14 mm. And for the dental reconstruction, the discrepancy was between 0.01 to 0.58 mm. As per the forensic, talking from the forensic context, 1 to 2 mm of discrepancy is the accepted range for the forensic analysis. Further, we did the digital analysis. We performed a qualitative congruency analysis test where the overall morphological error showed was 1.5 mm for the skeletal remains, and for the dental remains it was 0.052 mm plus or minus 0.5. Further reassuring that these models were the reconstructed models were accurate and were near to the original models. Now, extending our work at the laboratory, in the archives of the laboratory, we had this fragmented non-human specimens that from the anatomy of the fragments, we can at least say that this specimen was of the non-human origin. So as per the workflow, we 3D scanned this 3D scanned these fragments and reconstructed it. After this, we printed the whole reconstructed model and we performed the analysis or identified the cranium. So following the literature review, the morphology of this reconstructed and printed cranium was consistent to that of the morphology of a domesticated dog. Further, we did the metric analysis on this and compared it with the definition of the metrics provided by two authors, which were confluent with the dog, except for the cranial width. The detailed analysis has been mentioned in this particular article. So from this, we were able to say that the fragments of non-human origin that were present in our lab archives were that of a dog. However, to determine the breed of the dog is still controversial. For the cranial width, we were able to say from the printed non-human skull that it might the deviation was in the cranial width was due to the trauma pattern to the skull. Next, the second part of the reconstructive forensics is missing elements or the reconstruction of the missing elements. To talk about this, we have conducted a couple of studies. The first study was conducted to reconstruct a missing tooth. So for this, we simulated a situation where the tooth was missing. It was a mandible, and we did a CBCT scan for this as we required the internal morphology of the sockets. We printed the sectional part of the mandible, after which all the analysis was done on this, or all the procedures were performed on this 3D printed section. After which we took the impression of this 3D printed model, and from the impression was scanned, and we were able to extract the root morphology from the scanned impression. On the root morphology, we were able to reconstruct the whole tooth, keeping the reference as the opposing tooth and the opposing arch. And finally, we 3D printed this reconstructed tooth. To check the accuracy of this reconstruction, we definitely performed the morphological analysis, after which we did the metric analysis, which showed the error of 0.26 mm to 1.21 mm. We also did the radiographic analysis of this, where we placed this reconstructed teeth in the original mandible and checked for its radiographic adaptation, which can be appreciated through the arrows in the picture. After which, we did a digital analysis, a qualitative analysis showing the overall morphological error of 0.44 plus or minus 0.5 mm. The next reconstruction we did was of a bony feature. On the left, it can be appreciated that we had a skull which had a bilaterally missing zygomatic process. If one of the zygomatic process was present, we would have replicated it. However, we didn't have, it was bilaterally missing. So what we did was a template-based reconstruction where we took the skull of almost same age, sex, and the population, and we superimposed it and extracted the missing feature from the reference skull and placed it on the target skull, and remodeled the zygomatic process. After which we 3D printed this remodeled and complete skull, which can further be used for forensic facial reconstruction, as it now has a complete anatomy. Talking about the 3D printing and its future in forensics, now most of us knows that DNA is a confirmatory test that is done to establish the identification in forensics. So DNA extraction being a very invasive procedure, using this technology, specifically 3D technology, the printed model can be further used for analysis and code presentation. After DNA extraction, a part of the bone or the teeth or the chunk goes away. So we definitely don't have the physical evidence. We might have the data or the pictures. So your 3D technology would play a very important role, where we can use this printed model for the code presentations or for the demonstrative purposes. Virtual technology also offers an humanitarian approach to the forensic investigation, as there is minimal to no physical contact with the evidence, which ensures that the least damage is there to the osseous remains. Also, owing to the present COVID-19 times, the non-contact data acquisition and limited physical contact to the evidence particularly prevents the transfer of the potential biohazards. From an Indian perspective, we are having a developing and maturing forensic sector, which is confidently embracing these digital tools. At the Laboratory of Forensic Odontology at NFSU, we are aggressively testing this technology from a forensic perspective and get the valid results. We are also working on a proof of concept to assess the viability of using this 3D scanning and working on the admissibility to the court. Thank you once again. On a closing note, I would like to thank Dr. Abraham Johnson for being a wonderful mentor during the project, and NFSU SSIP committee for supporting during the project.
Thank you, Dr. Gargi, for providing your insights on the 3D virtual reconstructive forensics. Now, with the ever increasing crime rate in our society, the field of forensic science has always been evolving. And as mentioned by all the three panelists, Professor Jithan, Rachel, and Dr. Jani, crime scene investigators and the forensic examiners have used 3D printing technology in various areas, be it in accident reconstruction or for the replication of crime scene evidence, be it in replication of a skeletal remain or a facial reconstruction from the unidentified skeletal remain. Now, creating replicas of evidence is not a new practice as such when we talk about in forensics. However, casting has its own challenge and limitations. Casting is not always possible or practical in cases where the substrate such as soil quickly deteriorates or is prone to deformation, be it the skeletal remains. So in these cases, time is a factor when we talk about some taphonomic changes. So 3D printing technology offers a great solution to these challenges. The National Institute of Justice from US is already funding a lot of projects that uses 3D printing for forensic application. So with this, let me once again thank all the panelists for being with us, for sharing their expertise and sparing their valuable time. So if we have any questions from the participants who have joined for this particular session, can put down in the discuss the chat box itself, and maybe the panelists can take up the may answer the question. Any question from the participants? Okay, I don't see any questions. So let me thank once again all the panelists, Professor Jason, Rachel, and Dr. Jani for being with us. And I now call upon Dr. Shibu to take over the session.